are multiplying. However, we have this exponent involved as well, so we have to understand what the exponent tells us to do. So in this case, this is our base, negative 6/10. The exponent of 2 tells us that we're multiplying negative 6/10 twice. And so we multiply it by itself. And so when I have two negatives, see how the negative sign's inside the parentheses, that means it's two negatives. That'll make a positive. And we're just multiplying 6 and 6 to make 36, and then moving the decimal back 1, 2 spaces, the number of places that are behind, the decimal is behind. And so 36 hundredths is the answer. So in this next one, same sort of thing. We're multiplying a negative times a positive, so we're going to end up with a negative, and you just multiply it like you typically would. And so I know the answer is going to be negative because I have one negative, and when I go ahead and multiply, I get 32, carry the 3, 2 times 8 makes 16, plus 3 makes 19, and then I move the decimal one space over because there's only one number after the decimal to make negative 19 and 2/10. Looking at this next one, it's fractions, so there's some cross-canceling that occurs here. The 5s divide into each other, and 2 goes into 8 4 times. And so multiplying across, now again, when everything cancels, you have 1s. So multiplying across, we get 1/4. Again, the negative signs cancel. Here, 2/3 is squared, so we're doing 2/3 times 2/3. So you're multiplying straight across, and that leaves us with 4/9. Look at this one. This is a square root symbol, and it's asking us for the square root of 1600. So the square root of 16 is 4, and the square root of 100 is 10. And so we can break it into those that radicand into two different factors, and that gives us 4 times 10, which makes 40. That would be the answers. So in this one, 625, a good one to remember, is 25. 25 times 25 makes 625, and since the negative sign's outside the parenthesis, or outside the radical sign, it's going to be a negative 25. Now the plus minus sign just means that our answer is going to be plus or minus. Now the square root of 144 is 12. So the square root of 1.44 is going to be 1.2. See, if I did 1.2 times 1.2, you end up getting 144, and then you have to move the decimal back 1 2 spaces. So that's how we're getting the 1.44. Again, the plus or minus sign in front just gets brought down. So this one, the negative sign gets brought down, and you're basically taking the square root of these individually. So you got the square root of 16 and the square root of 49. So the square root of 16 makes 4, the square root of 49 makes 7. So negative 4/7. So looking at the other types that we'll end up seeing here, we've got a division problem. And with division, the divisor is the second number. So I'm dividing negative 10 into negative 1 7/10. And so the negative signs will cancel. I bring the decimal point straight up. 10 does not go into 1, but it does go into the 7s. Let me fix that. So it goes into 17. So 10 does not go into 1, but 10 does go into 17. It goes in there one time. And then we end up having 10 left over, and then we bring down the 7. And so when we do this part, we have 70, and 10 goes into 70 7 times. So when I divide by 10, the decimal is basically moving to the left one space. So you can see that's the case. Same numbers, just decimal point moved over one space to make 1700ths. On this one, no cross-canceling is occurring because, well, it's a division problem. So we've got to go ahead and change it to multiplication first. So when I do that, I'm going to multiply by the reciprocal. And so there I've taken the reciprocal. Now I can look for cross-canceling, and I do see some. So I see that I can go ahead and cancel out the 3 goes into 9 3 times. 8 and 10 share a common factor of 2, so I can divide them both by 2. And then multiply straight across. And so when I do that, I'm left with negative 1 and negative 5 make a positive 5. 4 times 3 makes 12. So 5/12. Last problem here says at 6 p.m. the temperature was 55 degrees. At 11 p.m. the same evening the temperature dropped down to 40 degrees. What real number represents the average change in temperature per hour? Okay, so per hour means we've got to find out how many hours there were, so, and the change in temperature as well. So let's take a look at the change in temperature. Degrees Fahrenheit. This is my symbol for change, and you oftentimes see that in science classes. So change in temperature went from 55 degrees to 40 degrees, and so it's going down, and it went down 15 degrees Fahrenheit. And so now we're looking for the change in time. And so the change in time went from 11, or actually 6, to 11. So if I subtract those, I have 5 hours. So 5 hours I'm looking at. So I want to find the change in temperature per hour. So we're going to do 15 degrees Fahrenheit divided by 5 hours. And that gives us, it's going down 3 degrees Fahrenheit per hour. Now, I can write it this way. The down tells us that it's going to be a negative. So that means you could also treat this as negative 3 degrees Fahrenheit per hour. So that would tell the reader that, oh, it's going down 3 degrees Fahrenheit per hour. So that's the types of problems that you're going to end up seeing on this homework assignment. Good luck.